Hi, this is a second session YouTube Shorts Tangent-2. Today we are going to talk about the tangent space to a graph surface, because any surface in R3 is only a graph surface. The argument which you give will actually work for any kind of submanifold of Rn which arises as a graph of some function. Okay, but the best reference will be two of my articles. Just search for tangents. There will be two articles. Okay, download it from usual MTTL site which I give in other videos. Okay, since it's a short, I want to spend more time. Let me start. So we are looking at a surface. So you let f be a function u in R2 to R. Assume it's a C infinity smooth. Okay, minimum at least C1, etc. Okay, then this surface is the graph surface. Okay, x in u. This x, if you want, think of as x1 x2 rather than x2 y, so that you can do it. This is a subset of R3. Okay, now tangent space, let's look at curves. Smooth curves, of course. By smooth curves I mean C1, C infinity, etc. minimum C1. Okay, so let's fix a point a in u. Okay, and then look at the point f comma fa in the surfaces. If you think of a1, a2, f of a1, a2. Okay, this is the point. So I want to look at this to the surface, and this should be, when I say this is smooth, this is as a function from here to here. Okay, because for S we have not yet defined anything. Okay, therefore as a function from minus epsilon plus epsilon to 3, it should be C1, C infinity, or whatever it is. Okay, now gamma t I can write as x1 of t, x2 of t, and f of x1t, x2t. Right? Therefore gamma prime t is x1 prime t, x2 prime t, and by using chain rule, t going to x1t, x2t, that going to f of this object. Therefore by chain rule I have dou f by dou x. So let me write dou f by dou x, okay, as a single notation fx, dou f by dou y as a similar notation fy. Therefore dou f by dou x at the point whatever it is, x1 of t, x2 of t, into x1 prime of t plus fy at the point x of t into x2 prime of t. X of t is x1t, x2t. Now we'll assume that gamma of 0 is my point a comma fa in S, right? Therefore I want to look at the tangent vector to gamma at the point 0. Therefore I have to look at this. That's going to be x1 prime 0, x2 prime 0, and fx at the point a into x1 prime 0 plus the partial derivative f at the point a and x2 prime 0. So this, as usual, you can write as x1 prime 0 into 1 0 fx into at the point a plus x2 prime 0 into 0 1 fy at a. Okay, therefore any tangent vector at a comma fa is of form, okay, some constant alpha times 1 0 fx at the point a plus beta 0 1 fy at a. Do you understand this? Yeah, right. So the tangent space, okay, at the point, let me call P as a comma fa, that is in the surface S. So Tp of S by definition is, okay, all possible linear span of, let me call this as, okay, a tangent vector okay, t, let me give a name E1, this call it as E2. Okay, these are vectors E1, E2 are vectors in R3, linear span of E1 and E2. Okay, now how do I understand this? The first thing is, look at that, right? Gamma t, x of t, f of x of t, whereas I said x of t is x1t, x2t. Okay, then just to project it onto the first two coordinates, that onto u, namely x of t, not onto to u. Okay, x of t, call it c of t. Therefore, now x of 0 by definition is a, because gamma prime is a, f of a, therefore x prime 0. Therefore, I can think of this as a curve like this. So I have something like this, and this is my u, and this is my surface. This is the point a, and this is my point a comma f a. Okay, and this is my curve. This is 0 minus epsilon to plus epsilon. This is a curve gamma, and this is the tangent vector, and this is a curve. Let me delineate it by different thing. This is my c of t. This is the projection. Okay, therefore there is a one-to-one corresponding between curves in S and curves in C, in U. Right? Okay, this is what the tangent space is. Now if you look at this curve, this is U, and let me look at this point A. I have two objects. This is A plus TE1, and this is A plus TE2. So call this curve C1, this curve so C2. Then I have the corresponding thing. Okay, this may be my A, this may be my C1 gamma, this may be my gamma 2. Alright, now, so what is my gamma 1t? Gamma 1t f of c1t, that simply means it's going to be a1 plus t, a2, f of a1 plus t, a2. Right? Therefore, gamma 1 prime 0, you can see is nothing other than 1 0 x at a. Similarly, gamma 2 prime 0 is 0 1 fy at a. Therefore, these are called coordinate curves. So what you have seen is that my TP of S, this is the tangent space to S in R3 at the point P equal to A comma F A is, okay, R of E1 plus R of E2. You can see these are linearly independent. Okay, but we have the notion of tangent plane to S at P. So this is the thing. Then the tangent plane is something like this. Maybe I should use a different color. This may be my tangent plane. That is the first order of approximation. How do I get it? To get this tangent plane to S at P is P plus TP of S. That if this is the tangent plane, this is the tangent space, phase, you simply translate this through P. This is my P, okay, through that. You remember equation of any plane in R3 is given by D, right? So if A, B, C are not all 0, so if you think of this is the normal. Not necessarily unit normal, but to the plane. Right? Now I have the tangent space, TPFS, it was spanned by E1 and E2. Therefore, what is the normal? Normal is given by E1 cross E2. That is, you have 1, 0, Fx and 0, 1, Fy. Therefore, this is given by minus Fx, minus Fy and 1. Right? And therefore, the equation of a plane is given by set of all x dot n equal to some d, but the d, if I know a point P on the plane, this is given by this d is nothing other than n dot P. Right? If P has to be on the plane, then P dot n must be d. So I know this. You understand that? Write it as P dot n. Therefore, what I have is this set of, let us say, x, y, z into minus fx, minus fy and 1 should be equal to minus fx, minus fy 1 into a, b, f of, okay, a1, a1, a2, f of a1, a2. But for the time being, it may be, if you want to look at this, right, a equal to a1, equal to b1. So now a is not a vector, it's a coordinate, right? Then you will arrive at equating correctly. You will see x minus a into fx at a, b, plus y minus b into fy at a, b, plus f of a, b. This is the tangent plane. This is what you would see in calculus of two variables. And notice that this is a first order Taylor expansion. Expansion of at the point a comma b. I can take a lot more time, but I want it to be short. Please refer to those two articles. A lot more details will be there. I hope you enjoy this geometry.